So we will continue today the chapter of moment of forces. Okay, we have seen last time how to obtain equivalent systems. So if we have a system of force, we can reduce it to one force, one couple. And we said that in this case, what we can do if you want to reduce a system of moment and couples for a point, the condition is when moving any force to a point, we should add its couple about the point. This is the only condition. Because when you put all forces at O, for example, to have equivalent systems, you should add the moment of these forces about O. Now, if you have couples, moment couples, what I mean by moment couples are moment created by couples of forces, and they are represented by moment vectors. Moment vectors, which are due to couple forces, are free vectors. This means that on this body, if I have this couple acting at this point, when I do sum of moment of point about O, I will consider it as it is. So I take M1 plus M2 plus moment of these forces about O. Now, when I finish, I will reduce my system to one point. I will obtain a force vector and a moment vector. Now, in case of 2D, when all your forces are in one plane, always the moment vector will be perpendicular to the force vector. And we will see that we can do something to, we can move the force in a way to remove the couple. So we can reduce in 2D, we can always reduce our system to only one force, and we will see how. However, in 3D, we can have a force and moment that are not perpendicular. In this case, we say that we can only reduce the system to one force and one couple that is parallel to it. Let me explain this. If you look at this figure here, you have the force is perpendicular to the moment. If you displace this force along this direction, okay, you can find a location where this force can produce this couple about this axis. Try with your hand, okay? I should displace the force in this direction or in this direction to obtain a couple MO in this way. Look, if you put your right hand, if you take it, and you put your four fingers along F, if you displace towards the right, the moment you will create will be in which direction? In this one, okay? However, if you take F backward, and you apply the right hand rule, you will obtain that you are turning in this direction and your thumb will act inward, okay? So here, if you want to reduce your system only to one force, what should you do? You should displace F along this axis with a certain distance D in a way that F times D equals to the moment. Because we said to obtain equivalent system, what is the condition? We should have the same resultant force and we should have the same resultant moment. So if I want to find a location where I can replace my system by only one force, what will be the condition? At this location, the resultant should be equal to Fr, and the moment of Fr about O should be equal to MO, M resultant at O. So you can say that from this condition, I can say that Fr times D should be equal to M resultant at O. So I did use the distance D that I should displace my force in order to replace my system by only one force is D equal to M resultant at O over F result. Okay, so you can see here that I am able to reduce my system to only one force, and this force will replace all the forces and couples. Now, In which case I cannot reduce my system to only one force. We'll see together now. If you work in 3D, okay, sometimes you might end with a force and moment that are not perpendicular. And you know that a force can only produce a moment that is perpendicular to its line of action. It cannot produce a moment parallel to its line of action. This is why we say that in 3D, sometimes we cannot reduce the system to only one force. Why? Because if I take this example, I reduced at O, I obtained F resultant and resultant moment. Okay? But as you can see here, they are not perpendicular. So what can I do? I can divide the moment into two components, one perpendicular to the force and one parallel to the force. And now I say F can never produce a moment parallel to its line of action. So it cannot produce a moment about Z. This is why this moment I cannot get rid of. Okay? I will always have, when I reduce my system at one point, I will always have this couple which is parallel to the force. But what I can eliminate is the moment that is perpendicular to the force. Because as you can see here, if I move F in this direction, it will, and I do the right hand rule, it will produce a moment about this axis. And the condition to have equivalent system is that I should move the force F a certain distance d in a way to produce this moment vector along a axis. Okay? So here I have the moment here along A. This is MA. If I want to replace my system with only one force and one moment that is parallel to it, I can displace the force in a way to create MA. So I will say that the condition to obtain the distance d is that Fr times d is equal to MA. So the distance d, I should displace the force in order to replace the system of F and this moment by one force is d equal to MA over Fr. Okay? And now I will still have the moment component that is parallel. This one, I cannot do anything for it. It will always remain here because a force can never produce a moment parallel to its line of action. And because it's a free vector, I can put it at point P as it is. So the moment vector is a free vector. You can put it at any point you want. So in this way, you have reduced your system at P, okay, to one force and one moment that are parallel. And this system is called a wrench. Okay, so the wrench is a system of one force, one moment that are parallel and that are reducing the system of all forces and couples to one force and one moment parallel to each other. Any question on this?
Yes, doctor.
Yes.
I'm not getting how you're using the right hand rule to pick which direction I should go.
Did you try to see the YouTube link that are explaining how to use the right hand rule? You know how to use it?
Yes,
Okay.
yeah, I know how
So,
to use the right hand rule, but here ما عم
okay.
تزبط معي.
Okay. Look, if you take here, if you take FR and you want to find the moment of FR about this axis, what do? You take your right hand, okay? You put your four fingers along F, okay? So if I want to draw them in a certain way, these are my four fingers. I put them along F. This is my hand, my right hand. My right hand is facing A axis, okay? Now, try to put your four fingers up in the direction of the force. Your thumb will be directed in which direction? It will be like this. This will be your thumb, okay? It will be if you want, let me put it like this. It will be parallel to, this is your thumb. It will point in this direction. Okay? So just, it's very simple. Put your right hand, 4 fingers along this direction, and your thumb will point parallel to A, directed towards the left. Okay? This is why you say, if I want to produce a couple in this direction, I should move D in this way. If your couple was like this, then to create a couple in this direction, you should put F backwards. So you should move in the backward direction. Why? Because if you use the right hand rule, then if I draw the hand, this is the 4 fingers. Okay, and your thumb will be directed like this in this case. Okay, so always you should try to use the right hand to know in which direction I should displace the force.
Okay.
Okay.
Thank you.
Welcome. Let us do an example on this. Replace the couple end force by an equivalent single force applied to the lever. Determine the distance from O to the point of application of this force. So as we said, always in 2D, we can reduce the system to only one force. What is the strategy? First, I select any point on my figure. Let's say point O. Okay? In a first step, I reduce my system to one force, one couple applied at point O. So here, if we look at our figure, okay, you have the couple of 200 Newton. This couple is creating a moment in which direction? In the clockwise direction, okay? Because look, I'm rotating like this. And the value of the couple is 200 times what? Times the distance between the two forces. The perpendicular distance between the two forces is equal to the diameter of the circle. It's equal to 120 millimeter or 0.12 meters. So here I should multiply by 0.12. So I get that my couple vector is in magnitude equal to 24 Newton meters. And this is a free vector. It means that if I'm doing sum of moment about O, or if I am doing sum of moment about B, I should consider this couple. Okay? Now, we decided to reduce at point O. If you want to reduce our system at point O, first we find the resultant force. Okay? As you can see here, the 200 Newton forces will cancel each other. So I only have the force of 400 Newton. So F resultant is equal to 400 downward. Okay? 400 Newton downward. Now I want to find the resultant couple at O. Okay? I can say that M resultant at O is equal. It's equal to the moment of the couple, which is here 24, plus what? Plus I should add the moment of force about O. Okay? I have that the 400 Newton force is creating a moment about O equal to what? To find the moment of this force about O, I should find the perpendicular distance. So if I take, this is the 400 Newton line of action. If I take the perpendicular, this distance is equal to what? I have here, this is 300 millimeter, okay? And I should find, the angle is given here to be 60. So this angle here is, this is 60 degrees. So I can say that this distance is 300 cosine 60. So this distance here is 300 cosine 60. Okay? So now I can say, I can replace here the resultant moment about O. I will choose a positive direction for my moment. I will choose the clockwise direction as positive. So I will put close to my equation my positive direction. This is the positive direction I am considering. So it's equal to 24 plus 400 times the distance, which is 300 cosine 60. Okay, so now you can find the resultant couple at. What I did until now is I reduced my system to one force, one couple acting at point O. Okay, now the
دكتور
next
clockwise
step.
direction مانا negative.
لا ما اثنيناتهم clockwise. أنا نقيت ال clockwise as positive. I specified here the positive direction as my clockwise. Okay, and both couples are rotating in the clockwise direction, so it's a plus. If you consider the counterclockwise as positive, then you put minus and minus. Okay, and since you get a negative result, you will say that my resultant couple is in the clockwise direction. Okay, now once I reduce my system to one force, one couple at point O, I did not finish because they said reduce the system to only one force. Replace the couple and force by one single force without moment. Okay? Since I want one force without a moment, what should I do? I should displace my force on the lever in a way to create the same couple about O. Okay, because they said we want to find the one force acting on the lever and giving us the same equivalent system. Okay, so what will we do here? We will say we should displace the force in a way to create the same couple about O. So if I displace the force a certain distance here on my arm OB, if I displace it at a certain distance x, how to find what should be x in order to have the same system, equivalent system? I say that when I displace my force a distance x, I can say that I only need one force to represent my system. To have this, the condition is that the moment of this force about O should be equal to 84. Okay, so here I say the condition for equivalent system is that the moment of F about O should be equal to M resultant about O, which was calculated to be 84. Okay, so now I can say that it's equal to the force F times the projected distance D. Now, if I look at my figure, this is D. Okay, D is the projection distance from O to the line of action of F. It can be calculated from its x cosine 60. So I can say this is equal to, I replace F by its value 400 times x times cosine 60. The only unknown in this equation is x. So in this way, I found what is the distance I should displace my force on arm OB in order to have a one force replacing the whole system. Okay, any question on this?
Yes, أنا ما فهمت آخر شيء دكتور شرحتي.
Okay, I will repeat. I reduced my system to one force, one couple at point O. But the question was to replace the system by only one force without a couple. If you want to replace your system by only one force without a couple, the condition is that it should produce the same effect of your system. Your system was reduced at O to one force of 400 Newton and one couple in the clockwise direction of 84 Newton meters. If you want to replace the system by only one force, what is the condition? The condition first is that the force should be equal to the resultant force you have, which is 400 Newton. This is the first condition of equivalent system. The second condition is that the moment of this force, okay, should be equal about O, should be equal to the resulting moment calculated about O, okay? So to meet the first condition, it's very simple. You keep the force of 400 Newton as it is, and you displace it on OB, okay? So you displace this force in OB. How to know which point I should act on in order to produce the same effect about O? The condition is that this force, when I displace it, and it will replace my system, I replace it only by this force. The condition is that this force should produce this couple about O to have the same effect of my previous system. Now, I know what is the couple. The couple is 84 Newton meter. I want that this force creates the same couple about O. So what is my condition? I will write that the condition is that moment of F about O should be equal to 84 Newton meter. Okay. Now, what is the moment of this force about O? It is the projected distance times the force. And the projected distance is equal to, since this angle is 60 degrees, and I want to find what is the distance x I should displace the force with, I will express my moment function of x. So this distance here, the projected distance, is x cosine 60. And I can say that the moment is equal to the force, which is F, times the distance, which is x cosine 60. So if I replace, it's equal to 400 cosine 60 times x. Your only unknown in this equation, as you can see, is x. So you found what is the distance I should displace the force with in order to replace my system by only one force. Okay? Any other question?
بس ليه 84؟
لأنه شو هو resultant couple about O؟ ما عملنا له calculation. What is the moment, the total moment about O of your system? If you go back to your figure, it's equal to the moment of the couple, which is 20 times the 2 times the radius, 200 times 120 millimeter times 10 minus 3 to convert to meter. The moment of your couple is equal to 24. Okay, you should add to this couple the moment of the force F about O. What is the moment of the force about O? We did the projection distance. It was 0.3 meter cosine 60.
بس
Okay.
دكتور عرفنا كيف جبناها، هذه مش الان ريزولت جبناها.
معهم مع بعض 24 و 60. What do you get?
Yes, I know.
Okay. So you know that the couple about O is 84. Your force, if you want to replace your system by only one force, this force should produce the same moment about O. Because if it will not produce the same moment about O, you don't have equivalent systems. Because the condition of the equivalent systems are to have the same resultant force and the same moment about any point in the space. In particular, if you choose O, you know that the total moment about O is equal to what? Is equal to 84. Because when you reduce your system to a force passing by O, this force cannot produce a moment about O. You have only the couple. The couple about O is 84. So if you want to displace your force in order to replace your system by only one force, the condition is that when you put your force here, it should still produce about O the same moment, which is 84 Newton meter. Okay?
Okay.
Okay, let us do an example on this. We have the following plate is subjected to 4 parallel forces. Determine the magnitude and direction of the resultant force equivalent to the given force system and locate its point of application on the plate. So here we have a plate subjected to several forces. We want to reduce the system to only one force. Okay? So the first step, as usual, is to find F resultant. F resultant here is equal to the summation of forces. And as you can see, all forces are parallel to Z. Okay? So the resultant force will be along Z and it's equal to minus 500, minus 600, minus 400, and plus 100. Because all forces are downward, expect the 100 Newton force is upward. So you get here minus 1,400. So your resultant force is equal to 1,400 Newton downward. Now, the second step, okay, this is the resultant force. I repeat, always when I tell you replace the system by one force, you should, in a first step, reduce the system of forces at one point. You can choose any point you want. Here, the easiest point is the origin of the frame, okay? If you want to reduce to O, if you want to reduce your system to point O, you found the resultant force, you still need to find the resultant moment at O. Because if you displace all your forces to point O, then you should add their moment about O, okay? For this reason, we will calculate the moment about O. And you know that in 3D, the moment about a point is divided into three parts. Moment about X, moment about Y, and moment about Z. Okay? Here, in this problem, you have two choices. You can do the vectorial method, okay? But because your forces are very simple, they are not complicated, you can use the conventional method, and we will see how, okay? So first, since all your forces are parallel to Z, you can directly say that M resultant in Z direction about point O is equal to what? Is equal to 0. Okay? Now, if I want to find the resultant moment along X, M resultant along X. First, if I look at my figure, I have the 500 Newton force is passing by X-axis, so it cannot produce any moment about X. Okay? You have the 600 Newton force also passing by X, so it cannot produce also a moment about X. You only have the moment created by the 100 Newton force and the 400 Newton force. Okay? Now, if you want to know what is the moment of the 100 Newton force about X, what should you do? You should multiply 100 by the distance between the X-axis and this force. And as you can see in your figure, okay, from the dashed lines, you have that the distance from the force to X is equal to this one, is equal to 5 meters, okay? So to find the moment of this force about X, you should do 100 times 5. Now, in order to know if it's positive or negative, you do the right hand rule. And so you put your 4 fingers along this direction and your hand facing X-axis. So do it like this, okay? If you do it like this, your thumb will point in this direction, okay? So this is the right hand rule. Your thumb will point in the positive X direction. So for this force, it's a positive moment, okay? Now, for the 400 Newton force, the distance you should take is this one to X-axis. It's equal to 10. But as you can see here, if you want to do the right hand rule, because your force is downward, you will put your 4 fingers like this, down, okay? And your thumb will be directed along the negative X direction. So it's producing a negative moment. This is why the resultant moment in X will be equal to 100 plus 100 times 5 minus 400 times 10. Okay? This is the resultant moment about X. I still need to find the resultant moment about Y. So if I look at my figure and I want to find the moment about Y-axis, first, for this force, 500 Newton, it's passing by Y, so it cannot produce a moment about Y. And also the 400 Newton force is passing by Y, so it cannot produce a moment about Y. You only have the moment of the 600 Newton force and the 100 Newton force. Now, to find what is their moments, first you find distances. For the 100 Newton force, I should multiply by the perpendicular distance, which is equal to 8 minus 2. It's equal to 6 meters. So here I should multiply by 6. And for the 600 Newton force, I should multiply by this distance, which is 8. Now for the direction. To know the direction, you should apply the right hand rule. Okay? So again, for the right hand rule, for the 400 Newton, it's upward. So you put your 4 fingers in the upward direction facing axis Y. Okay? Your thumb will be directed along negative Y axis. So you can say that the 100 Newton force is producing a negative moment about A. Now, for the 600 Newton force, you put your 4 fingers downward and facing Y axis. Then your thumb will be directed along the positive Y direction. So you will say that the resultant moment, M resultant about Y, is equal to minus 100 times 6 and plus 600 times 8. Okay? Now, what we did until now, we reduced our system. Okay? So if I want to draw it here, you reduced your system to one force and two moments. One along Y, one along X. Okay? So this is your reduction. You reduced your system to one force F resultant, okay, and to a moment M resultant along X, and a moment M resultant along Y.
Doctor,
Yes?
why did you take the resultant force only along Z?
Because all forces are along Z. Do you have any component? Do you have any component along another direction? All forces are along Z, so you don't have X and Y components for the forces.
Ah, yes, okay.
Okay?
Yes.
So, now, if I look at my system, okay, if you do your calculation, you obtain that M resultant X is negative, so I will put it in the opposite direction. You got M resultant negative, and you got M resultant Y positive. Okay? Now, your second step is, so here, if you want, this is along the negative direction. The next step is, after reducing to one resultant force at O, okay, and a resulting moment about X and Y, I want to try to displace my force in a way to have only one force replacing my system. If I want only to have one force replacing my system, what is the condition? The condition is that if I move this force in a new location, I should have the force creating the same moment about X and Y. Because my purpose is to replace the system by only one force, okay, that is producing the same effect about. So as a first step, I will say, this is MRX. I want to displace my force in a way to create this couple about x-axis. So first, I should move my force in which direction? To know, I should move it in a way to create a moment in the negative direction. So if you try your right hand rule, okay, if you move F in this direction, then if you take your right hand and you put your thumb, it will be directed towards the negative x direction. Okay, so of course I should move it in positive y and not in negative y. And even you can know this directly because your resultant force should be somewhere on the plate, because all your forces are on the plate. So you cannot have a resultant outside of the plate. So by logic also, you should move in the positive y direction. Now, to know how much you should move in the positive y, you know that the moment of a force about x can be calculated by doing what? By taking the distance, which is along y, times the magnitude. So you should say that to have equivalent system, resulting moment about x should be equal to Fr times y. Okay, so you deduce what is the distance you should displace your force with. So y should be equal to mrx, of course, in absolute value. Okay, so the absolute value of mrx over the force over Fr. Okay, so here, since mrx is negative, you will put minus mrx equal to Fr times y. Okay, now I still need to find what is the distance I should displace the force in order to remove mry. Okay, so if you have mry now, this is mry. Okay, you should displace your force along a distance x to produce this moment. So also for mry, what is the condition? You say that mry is equal to Fr times x. So x is the distance x I should displace in order to have equivalent system is equal to mry over F result. In this way, when I displace x and y, I am able to reduce my system to only one force without the need of any moment. Okay? Any question on this?